remember we talked about means and extremes in our proportions? These two spaces here, these are the means. So the geometric mean goes in both of them. 4 is to x as x is to 25. Oh, what's next week, please? Guys, I already saw a chip on my floor this morning. I asked you guys not to have snacks in here, and that's why. I had to plug holes with tape to keep the ants out of here. Martel, I asked you to put those away, please. Thank you. That means not eating them. Martel, take your hand out of the bag. Go in the hallway. Yeah. Thank you. So, guys, 4 is to x, x is 25. You solve this the same way we always do, cross multiplication. So x times x is x squared. 4 times 25 is 100. So what is the geometric mean of 4 and 25 going to be? Right, it's going to be 10. Right there. You guys see how that works a little bit? Again, don't think of geometric mean as an average. Think of it as proportions. Okay? 4 is to the geometric mean as the geometric mean is to 25. 4 is to x as x is to 25. Follow this. Make sure you get all these steps down so we can see it. I'm going to ask you to do a couple examples like this on your own. Just like we did with proportions, we're starting out with just the numbers, and then we're going to talk about it as it relates to geometry. All right? So I'm going to come around and make sure we have all this down. Example, get down. All right, so hopefully that's somewhat clear. Now, what does this look like? Okay, so the geometric mean is an altitude. If you want to talk about it as a picture, that's what it is. Geometric mean is an altitude. Okay? So right here, we don't know what this length is here, but we can find it because it is the geometric mean between these two numbers, 12 and 4. Okay? And I'm going to show you guys, it's going to seem a little bit like random, but it's going to seem a little bit complicated how I set this up. But right now, how would you set up a proportion to solve for x if it's the geometric mean? Remember how we did it before? We looked at 4 is to x as x is to 25. So in this case, what would you do? 4 over x, and then x over 12. And that's the same we're going to do here. Watch how we get there. We know that with similar triangles, which we've studied, they have to be oriented the same way, right? They have to be like facing the same way so we can just make corresponding sides. So here's how I'm going to solve this. Here's how I'm going to set this proportion. First thing I'm going to do is split this triangle in two. And I really need you guys to show these steps. Okay? So you have this triangle here. And what I'm going to do is just split it up. So now I have just 2 of these lengths that are x. Does that make sense? Okay. Come on, it's down. You got to have this. Huh? Right. Then say that a little bit louder, Juwan. Thank you for mumbling that. I'll say it a little bit louder. Now we can use proportions, just like we have been doing. But not quite yet, because look, in this case, my hypotenuse is on the left side. But where is it over here?
On the right.
It's on the right side. So what I need to do is I need to orient these triangles the same way if I'm going to set this proportion. Okay, so I need to flip this triangle. Okay? So when I do that, now look what I have here. Where are my right angles down here at the bottom?
On the right.
They're both in the bottom right. So if we look at this proportion, we can see how it gets set up. 4 is to x as x is 12. And that's in the right order for a geometric mean. So guys,